study recursion in C and how it is implemented in structured programming approach. Now what is recursion? Recursion is a process of repeating itself in a self-similar way. That is, when a program allows you to call a function inside the same function, then it is called a recursive call of a function. We'll see how this recursive call is made. But before that, let's see the few features of recursion. Recursion is more elegant and requires few variables which make the program clean. Recursion can be used to replace complex nesting code by dividing the problem into the same problem of its subtype, that it remains with the modularity of the C programming. If a program allows you to call a function inside the same function, then it is called as a recursive call of that function. Now this is an example for the structure of a recursion. We have a main function over here which is used to call. This is my int main. This is a main function, and this is the name of the function which is being called. We say recursion. This is a call to the function. So from here the control is transferred to the function definition over here, and you will see that void recursion, and again there's a call to the function. So when a function calls itself, it is known as recursion. To complete a particular task, I'm calling this particular function again by itself. There are few problems which can be solved very easily using a recursion. Now let's take a factorial of a number and see how a factorial of a number can be solved using a recursion and how easy it becomes. We start with the main program over here. This is a factorial function which is written, and this is the integer main. The declaration of the integer main starts from here. Int of I is equal to 5, which means that I need to find out the factorial of a number 5. Print factorial of %d is %d. Here is the variable whose factorial I need to find, and this is one way of calling a function. So I say factorial of I. As this function name is written over here, the call to my function is given, and the value of I is passed on to this particular function definition. So I gets a value of 5. We enter that function, and if I is less than or equal to 1, but my value of I at present is 5. So we enter the loop. The return I is not there. Function value of I is not less. So we come over here. We say return I into factorial of I minus 1. So I has a value of 5 and factorial of I minus 1. So 5 minus 1 is 4. So now factorial of 4. From here the function is called itself. So now I gets a value of 4. It comes over here. Now the next value of I to be checking over here is 4. So is 4 less than equal to 1? No, 4 is greater than 1. So we again come over here. So 5 multiplied by this value of 4 and then into factorial of I minus 1. So now 4 minus 1 is 3. So now the value is 3, and again there is a function call with a value 3. So 3 is again not less than equal to 1. So it comes back here. So 4 into 3, and now again it's 2. 3 minus 1 is 2. So it is 2 over here. With a 2 it gives a function call again. So it goes to the function itself. 2 is not less than equal to 1. So it comes back here. So it is 3 into 2. And now 2 minus 1 is 1. So it goes over here. And it says 1 is less than equal to 1. Yes, 1 is equal to 1. So return 1. So 5 into 4 into 3 into 2. The value is 120, which is returned over here. And here factorial of I, which is d, is 5. The value is 120. It's printed over here and return 0, as it is an integer main written over here. So it is return 0 and function ends over here. This is a recursive way of calculating the factorial of a number. Now let's see how the recursion works for a Fibonacci series. We have a Fibonacci series over here, And if I have to print 0, 1, 1, 2, 3, 5, 8, 1, 3, 2, 1, how do we do it? So this Fibonacci series works from here. Fibonacci of I is 0, which is passed. If I is 0, return 0. So I will be printed. If I is 1, return 1. So 1 will be printed. And now we go to the next one when I becomes 2. When I becomes 2, it is 2 minus 1 plus Fibonacci of I minus 2. So the value is the addition of Fibonacci of 2 minus 1 is 1 and Fibonacci of 0. So these two numbers will be added. So 1 plus 1, you get 2. So this particular thing will work in the loop till all my series of 10 numbers will be completed and I get a series of 0, 1, 1, 2, 3, 5, 8, 13 and 21. Let's see sum of n natural numbers using recursion. Now what is sum of n natural numbers? Whatever n I enter, and n will be my positive integer over here. So here is my function declaration and I call the function main. We've declared the local variables as num and result. Enter a positive integer where n is sum of 10 natural numbers. Let's say if I enter number as 10. Some number. So I call this function number and number passes the value of 10 over here. So my num gets the value 10. And if num is not equal to 0, my num is 10, so it is not equal to 0. So return num plus sum of num minus 1. Here it is 10 plus sum of num minus 1. So it becomes 9. Calls the function again. 9 is not equal to 0. So 10 plus 9. Now it becomes 8. So this will continue. So 10 plus 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1 plus 0. As it becomes 0, the addition of all will be returned to that particular number as this num will be returned to the function call over here. So it will be added to the result. And sum is equal to the summation of all the numbers will be printed over here. This is how sum of n natural numbers using recursion is done. Let's see a power of a number using recursion. That is 2 raised to the power of 2 if I need to find out, or 2 raised to the power of 4 I need to find out. So it is 2 into 2 into 2 into 2. So what will be the final result? So this is how it is done over here. This is the main program where integer base power, you will see it is declared as long integer because the power numbers can exceed -32768 to +32767. That is the integer range of numbers. So we have given it as long integers if 2 raised to any higher power or 3 raised to any higher power is taken. So we start with enter the base value. That is, if we are doing 2 raised to the power of 2, so 2 is my base value. Enter the value of power. Here I have entered the value of power as 2. So we pass on power 1. So power 1 is the name of my function. So I pass the base and the power value which goes to b and p. This is my another variable, similar variable which is local to main. It is again declared over here as local. If p is equal to 0, then return result, that is 1 will be returned. Else b into power of 1 b p minus 1. So this will continue. Now b remains the base 2. Next will be power of 2 minus 1, which will be 1. So b is 2 over here. Power of 2 and 1, this will be returned over here. So it will go back here. And you will see now b is 2 and p will have the value of 1 when I give a call back over here. So it again enters over here. P is not 0. So b into, so it will be 2 into 2. Now p minus 1, so p becomes 0. So now the function call will be with 2 and 0. So as p has become 0, so it will return the result. So 2 into 2 is 4. So that will be returned. So that result will be returned over here, and then it will come over here and it will be stored in this result as the function call. When I say return result, this return result will come over here. So it is printf to the power of 2 is 2 to the power of 2 is long integer, so the answer will be 4, and return 0 as my main is an integer function. So this is how the power of a number is found out using a recursion. Now let's see another program that is counts the digit of a number. So it will count how many digits are there in a number. So this is my function and this is my main function. This my main function is integer number, count is equal to 0, printf, enter the positive integer. I've taken the example of 112, so the total digits in the number 112 is 3. So digit count, I pass on the number 112 from here and it will go to this particular function. So this number is 112. If num is greater than 0, so my num is 112, count is initialized to 0. Count is, if number is greater, count is incremented by 1, so my count becomes 1. Digit count, so I'm again calling this particular variable. You will see I'm saying num divided by 10. So this will give me the quotient. When I say 112 divided by 10, that is 112, it is divided by 10. My quotient is, if I divide, I get the number 11, right? So what happens, it goes back. Now my number is 11. So 11 is still greater, count is incremented by 1. Now my count becomes 2. Again it is divided, so quotient is 1. It goes back, it is again greater than 1, greater than 0. So my count becomes 3. Next time my answer becomes 0. So it is not greater than 0. So it comes to the else part and it returns the count, and the count is 3. So we come over here, and for the positive integer number 112, the total digits are 3. This is how we count the digits of a number using a recursion. Now recursion for a length of a string, that is, I need to calculate the length of the string using a recursion. So this is my function. It is the similar way as we count the digits. Only thing is, here I have to count the string. So here the pointer is used till the string is not equal to length. Rest all the logic remains the same. We have an example over here. It is C programming and the total count is 12. Let's see sum of digits of a number. That is, if I have given 2, 1, 3, 6, the sum is 6 plus 3, which is 9, 9 plus 1 is 10, and 10 plus 2 is 12. That is the sum of the digits. So we enter a positive number, integer number, which is 2136 I've entered. We pass this number to a function, and let's see what happens. I pass it out, it comes over here. When it comes over here, it checks numbers greater, says yes. So sum plus is equal to num mod 10. You will see this will give me the remainder. If my number that I have taken is 2136, so when I say 2136, I take the mod function. When I say 2136 mod 10, my answer is 6. So sum is initialized to 0. So sum is equal to sum plus 6. So now the sum becomes 6. Then I say digit is equal to num divided by 10. So this will give me the quotient. So my quotient now becomes 213. And with this, I give a call to this particular function. Now with the 213, we again enter. We say num is greater. Yes, num is greater than 0. So what happens? As num is greater than 0, so it is, we can declare this variable on top because this is static. So this time when it is changed inside, this will not be reflected once the value is changing inside. So when I say 213, so 213, again we have the remainder. So remainder will be now 3. So 6 plus 3. And here the divisor will be now 21, which will be passed. So we again come down. So it will be 21 mod 10. So it will be plus 1. 2 is remaining. 2 divided. Again it is plus 2. So final answer will be 12. So it is now equal to 0. So it is not greater. It will come here. It will say return sum. And my answer will be printed as sum of all the digits is 12. This is the recursion to find out sum of digits of a number. So this is how the recursion works at various levels of programming. Thank you.